Hello, my name is Golsa Heydari, a PhD student at Leibniz University of Hanover, Germany. I'm gonna demo a faceted search system implemented on scholarly knowledge graphs. My colleagues in this teamwork are Ahmad Ramadan, Markus Stoker, and Zoran Auer. When you search, for example, in Google, you always look for the most accurate and relevant answer to your queries. Traditional scholarly search systems list documents instead of providing direct answers to the search queries. As data in knowledge graphs are not acquainted semantically, they are not machine readable. Therefore, a search on a scholarly knowledge graphs ends up in a full-text search, not a search in the content of scholarly literature. In this demo, I present a faceted search system that retrieves data from a scholarly knowledge graph which can be compared and filtered to better satisfy user information needs. It is implemented on a scholarly knowledge graph named Open Research Knowledge Graph, ORKG. I start by explaining why there is a need for structured scholarly knowledge and how it is structured. Afterwards, the faceted search system will be explained in details. Given described papers and their research contributions, it is possible to compare the contributions addressing a specific problem across the scholarly literature and automatically create such ORKG comparisons. Here you can see a paper by the title The Early Phase of the COVID-19 Outbreak in Lombardy, Italy. This paper is about COVID-19, and here you can see the content of the paper. In a graph view, you can actually see better that this contribution has four properties that are basic reproduction number, location, time period, has research problem. Such papers can be actually compared together. Here you can see a comparison of COVID-19 basic reproduction number as published in numerous papers, specifically the value and its 95% confidence interval, as well as the location and period of the infectious agent population. Such comparisons provide us with an overview of key information about a research problem across dozens or hundreds of papers and are thus a valuable instrument that can help for search. As you can see in these comparisons, all these papers are about COVID-19 and have common properties. The first one is location. By clicking on these filter icons, you can just filter the data about these properties. Wherever you see that this filter icon is broken, it means that there is no need to filter this property. First of all, we would filter location. Here you can see the data that is prepared in these papers. You can easily select or unselect the data and the location that these papers or surveys are done there. The next property is time period, which has beginning and end. For example, if you want to see the surveys that are done from the 1st of January 2020 till the 1st of January 2021, you can easily give this data for beginning and the end of these surveys. You can easily exclude some dates here, or you can use this calendar, which automatically choose date for you, or you can select date from it. Now you can see that the number of contributions or papers reduced to 12. The next one is has, and you can do the same as you did for the beginning date of the survey. The next property is basic reproduction number. You can select the amount between 2 and 5, and for example exclude amount of 3 or 4.5 and apply it. And again the number of papers reduced to 9. The next property is confidence interval. For lower confidence interval, I would select, for example, 1 and a maximum of 3, and I would exclude 3.3, 2.2. And for the upper confidence interval, you can do the same. So the number of these paper would go down and would reduce. Here you can see the method and approaches that these scientists selected for using these surveys. You can even filter these papers by method and approach. For example, you can choose the method that they use from this list. For example, growth or generalized, or you can easily do the autocomplete system, which is available here. You see that the number of papers reduced to 4. It means that these 4 papers carry the exact data that you mean. The content of these papers have the exact data that you filtered here. Here you can see the applied filters and the amount of data that you give to these used to filter this data. By hovering over each of these filter icons, you can again see the filtered data here, and for example the different color between properties that you filtered or you didn't filter is obvious here. And the important point is that you can copy this link and send it to your friends and other scientists to see the result of your search. They can easily copy it in a browser and see the exact data that you had here. If you click on one of these papers, here is a link to this paper in ORKG. Here you can see the metadata and data about this paper. The metadata is, for example, the publishing date, the research problem, and the name of authors, and the data which you can actually filter and search by using this faceted search system is shown here. By clicking on this DOI number, you can easily actually have access to this paper and the original paper and get data from it. Okay. In this project, we implemented a faceted search system over a scholarly knowledge graph. To ease information retrieval, facets adapt to content. The more the knowledge graph is implemented in details, the search results would be more fine-grained. You recognize that how this search system would be an alternative to the traditional method of search in literature surveys. In future work, we will federate knowledge graphs to further improve dynamic faceted search. For instance, we intend to use geonames to enable spatial filtering on a scholarly knowledge. I would be so glad to hear your feedback. Thank you for your attention.